Problem 152, Quantum Mechanics. The question is the radial wave function of hydrogen atom with the principal quantum number n is equal to 2 and the orbital quantum number L is equal to 0 is R20 is equal to n 1 minus r by 2a e raised to minus r by 2a, where n is the normalization constant. The best schematic representation of the probability density P of R for the electron to be between r and r plus dr is. In the present problem, we have to find out the probability density P of R for the state n is equal to 2 and L is equal to 0 for hydrogen atom. To solve this problem, first let us find out the number of nodes. The number of nodes is given by the equation n minus L minus 1, where n is the principal quantum number, L is the orbital quantum number. In the given problem, n is equal to 2 and L is equal to 0. Therefore, the number of nodes is given by n minus L minus 1, that is equal to 2 minus 0 minus 1, that is equal to 1. Now let us check the option. In option A, you have one node as predicted by the equation. In option B also you have one node. But in option C, you have two nodes. Option D, you have two nodes. Therefore, we can say that option C and D are not correct. Only option A and B are correct because the curve shown in option A and option B have only one node. Now we have to choose the correct option between option A and option B. For that, first let us consider the radial wave function for the hydrogen atom for n is equal to 2 and L is equal to 0. That is, it is representing the 2s state. R of R is a radial wave function and the shape of the curve is like this. This is the plot of R of R, that is a radial wave function with distance. Now let us find out what is the graph of R square with a small r. When you take R square, there will not be any negative part because R square is positive. Therefore, the curve contains only the positive part and the curve goes like this. Now let us find out the probability density P of R. What is P of R? P of R is actually 4 pi r square into r square r. This is the curve of r square r with r. Now just multiply the y-axis with 4 pi r square and the graph modifies to this shape. This 4 pi r square r is nothing but P of R is a probability density. Now we can clearly see that near r is equal to 0. Near r is equal to 0, the probability is lower and then the probability increases to a maximum. Now on comparing with option A and option B, from the shape of the curve, we can say that option A is the right option.